All right, tangent and cotangent graphs. Now, when we do tangent and cotangent, we're not going to graph everything as we go along. We're just going to get one final graph. We're going to do all the math, and then we're going to graph it. Okay, in the end. So your final graph will be graphed. So how do we do tangent? Well, y equals tangent of x. I'm going to make a list of what we get with tangent. So unit circles out, unless you know your unit circle by heart. So add 0. What's a tangent of 0? Tangent of 0 is 1 over 0, which is 1 over 0. Undefined. The world is a great place until somebody tries to divide by 0, and that's undefined. All right, pi over 4. What's tangent of pi over 4? 1. Tangent of pi over 2. What's 0 divided by 1? 0. 3 pi over 4. Negative 1. And then pi. Undefined. Because it's 1 divided by 0, right? Or negative 1 divided by 0, right? Or is it 0 divided by 1? Is this upside down? I think this is upside down. Because this is 0 divided by 1, right? Y divided by x. So this would be 0. And then pi over 2 would be undefined, right? Because tangent is y over x. And this would be 0. 5 pi over 4 is where we're at now. What's tangent of 5 pi over 4? 1. 3 pi over 2. Negative 1 divided by 0. Undefined. 7 pi over 4. Negative 1. 2 pi. 0. So let's graph this thing. So we got 1, 2, negative 1, negative 2, pi over 2, pi, 3 pi over 2, 2 pi. All right. So if I'm graphing this, I'm at 0, 0, pi over 4, 1, pi over 2, undefined. If I'm undefined, what is that? Because we had undefined basically with cosecants and secants. What do we draw where we're undefined? Asymptote. Okay, and then 3 pi over 4 is negative 1 pi. 5 pi over 4 is 1. 3 pi over 2, we have an asymptote. Then we're at negative 1, 0. If I continue on in the same pattern, should be like this, right? Okay, so if I'm going up at that angle and I've got an asymptote, what I'm thinking is I follow the asymptote, then I curve and I curve. So this is the tangent. Looks like this. Okay. I guess I could do it right here. It goes like that. But yeah, that's what a tangent graph looks like. We good? Okay, that's not too hard. Now let's do a cotangent graph. Zero, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. Cotangent of 0. This is where I screwed up last time. Cotangent of 0 is x over y. So it's 1 over 0, so it is undefined. Pi over 4, square root 2 over 2 over square root 2 over 2. 1. Pi over 2. So it'd be 0 divided by 1. 0 divided by 1 is 0. 3 pi over 2. No, not 3 pi over 2. Oops. 3 pi over 4, that should say. Mr. Bierschbach is good at screwing up. This is negative 1. Pi. Undefined. 5 pi over 4. 1. 3 pi over 2. 0. Negative 1. Undefined. Do you see how there's a pattern there? All right. So we have 0, 0. Nope, we have 0 undefined. So if we have 0 undefined, I have an asymptote right here on the y-axis. Then pi over 4, 1. Pi over 2, 0. 3 pi over 4, negative 1. Asymptote at pi. 1, negative 1, 0. Asymptote at pi, 2 pi. So the cosine and the tangent mirror each other, except for the cotangent has a negative. Cotangent has a negative slope. Tangent has a positive slope. And they're not quite in the same place. Okay? They're pi over 2 away from each other. One has a negative slope, or they're pi over 4 away from each other where the asymptotes are. Or pi over 2 where the asymptotes are, yeah. Pi over 2 away from each other where the asymptotes are. Negative slope versus positive slope, but that's what they look like. So, what are the problems that you're going to see? Okay. Well, let's say we have y equals 2 tangent of x minus pi over 4. All right. So, this is where we have to build things and then we graph it. So, we have x. We have tangent of x. We have 2 tangent of x. And we have 2 tangent of x minus pi over 4. Okay, this is going to look really complicated, but this way, if we do it this way, we only have to make one graph. So I start out with my normal tangent stuff. 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. And then I copy what my tangent was up above. And up above, tangent was 0, 1, undefined, -1, 0, 1, undefined, -1, 0. Okay, so I got all that copied. What does this 2 affect? The x's or the y's? The y's. It stretches it vertically, right? So if it affects the y's, we're going to multiply each of these y values by 2. So I'll get 0, 2, undefined, -2, 0, 2, undefined, -2, 0. Just multiply them each by 2. What does the pi over 4 affect? The x's or the y's? The x's. What does it do to my x's? Moves them to the right, pi over 4. So you take each of these and move them to the right, pi over 4. So then I just go pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi, and then 9 pi over 4. That's where they'll be. I'm just adding pi over 4 to each of my x values. So then when I graph it, this will be my x that I graph. This will be my y that I graph. If something happened to your x, your final x will be what happened to your x, and your final y will be what happened to your y. And so I did something to both my x and y. Some of your problems, you'll only affect the x, and so you'll only shift it. Or you'll only affect the y, so you'll just shift it that way. But here I had an x and a y, so I'm going to do it that way. Now I'm going to make my graph a little bit tighter now. I'll just go pi over 2 for 2 spaces, and then pi, 3 pi over 2, 2 pi, and then 5 pi over 2. There. All right. So I made it a little tighter. And I'm just graphing my final graph. So I'm going to start at pi over 4. At pi over 4, I'm going to be at 0. So at pi over 4, I'm going to be at 0. At pi over 2, I'm going to be at 2. So at pi over 2, I'm going to be all the way up at 2. At 3 pi over 4, I'm going to have an asymptote. So at 3 pi over 4, I'm going to have an asymptote. At pi, I'm going to be at -2. Five pi over 4, 0. 3 pi over 2, 2. Then another asymptote. -2, 0, 2, asymptote. So it's a really long and skinny graph. Okay, see how that worked? Okay, to see how that's my final graph. Let's do one more, and then I'll unleash the assignment on you. It won't be that many problems. Let's do this. Y equals negative cotangent of x minus pi over, let's go pi over 2, I guess. Negative cotangent of x minus pi over 2 plus 1. So you're going to start with your x, your cotangent of x. Then you're going to do a negative cotangent of x. Then you're going to do a negative cotangent of x minus pi over 2. And finally, then you're going to go the plus 1 in the end. So your x and cotangent of x, you just get from what we started with. So we start at 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. And the cotangent was undefined here, here, and here. Negative 1, 0, 1. Nope. I'm backwards. 1. So we're at, so it's 1, 0, negative 1. There we go. 1, 0, negative 1. So if I do a negative cotangent, what does that do to my undefines? Nothing, right? A negative times an undefined is still an undefined. A negative times each of these would go negative 1, 0, 1. Negative 1, 0, 1. That's what the negative does. So this affected the y. This is a y. This is an x. What does the minus 2 affect, x or y? The x. So we move everything pi over 2 to the right. Pi over 2 to the right. Minus pi over 2 is pi over 2 to the right. So then this becomes pi over 2. This is 3 pi over 4. This is pi. This is 5 pi over 4. This is 2 pi. This is 7 pi over 4. Whoop. Did I screw it up? Yeah, I did. Pi is not 2 pi, it's 3 pi over 2. And then it's 2 pi here. And then it's 9 pi over 4. And then it's 5 pi over 2. And then plus 1 takes this y and moves everything up by 1. Well, if you move an undefined up by 1, what is it? Still undefined. But negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. Undefined is still undefined. 0, 1, 2, undefined. So this is my final x and my final y that I'm going to graph, where those are at. All right. So at pi over 2, I'm undefined. And then at 3 pi over 2, I'm undefined. 5 pi over 2, I'm undefined. 3 pi over 4, which is right here. I'm at 0, then 1, then 2. 0, then 1, then 2. So it should look like that. Okay? All right. So let's figure out what I should assign today. Last new stuff for the chapter. Next time we'll do a chapter review. And then next Thursday you can do the chapter test. So, let us do 37, page number 144. Let's do 37 and let's do 43, 45. You know, it's early release. We'll call that good. 37, 43, 45, 3 problems. Okay. You've got 20 minutes or less to work on this. Get it going.